All right, now let's talk about experimental design, or the elements of a good experiment. And why do we care about this? Okay, so as a scientist or a researcher, we care because if we have a poorly designed experiment, we can't draw any conclusions from it. It was a total waste of time. Boo, right? That's no good. More specifically in this course, these experimental design considerations are important because you'll see these come up over and over again in our lab experiments. For example, we'll talk about positive and negative controls, and you'll see these words pop up in our osmosis lab, and the enzyme lab, and the photosynthesis lab, and more. Okay, so you'll want to recognize these and what their purpose is. All right, so one thing you need to think about when designing an experiment are the variables. Variables are components of an experiment that can be changed. There are two types, independent and dependent. The independent variable is what you, as the experimenter, change. On the other hand, the dependent variable is what you, as the experimenter, are observing, what happens during the experiment. So, for example, let's say you want to test the effect of caffeine on exam scores. So maybe you give students caffeine pills before they take an exam to see how that affects their score. In this case, the independent variable is the caffeine. That, maybe it's whether or not a student gets caffeine, or maybe the dose of caffeine as well. But it's what you, as the experimenter, are changing, manipulating in the experiment. On the other hand, the dependent variable in that example is the exam score. It's what you're observing change throughout the experiment. A good experiment also needs controls. A control is a variable that's held constant. And there are two types, positive controls and negative controls. A positive control is something already known to produce an expected phenomenon, whereas a negative control is something already known to not produce the expected phenomenon. Okay, so let's go back to the caffeine and exam score example. In this case, the negative control might be a group of students where you don't give them any caffeine. So it's a group where you don't expect them to have any change in their usual exam scores, right? And this is actually what you're really comparing your main test group to, is this negative control. The positive control in this example is a little bit trickier, right? Maybe in this case, you have another group of students where you study with them before they take the test, because study or practicing is already known to produce better test scores. And why might you want these different types of controls? One example is later on in the lab course, we use something called Benedict's reagent. Okay, this thing right here. Benedict's detects the presence of simple sugars in solution. Okay, so the idea is you add Benedict's to some solution, and if that solution has sugar in it, Benedict's causes it to change color. So what if you add it to some unknown solution and it doesn't change color? Okay, it probably means that there's no sugar in the solution, right? But it could mean that your Benedict's is expired and doesn't work anymore. And how would you know the difference? By setting up controls in your experiment. Okay, so you could include in your experiment a test tube with a sugar water solution, for example. You already know that there's sugar in that solution. This would be the positive control. So when you add Benedict's to this, you know it's going to change color. In this example, you also want to make sure that Benedict's is only changing color when it should change color. So maybe you have a test tube with only water in it. You would expect no color change because there's no sugar in that solution, right? It's just water. This would be the negative control. Okay, so now turn to your lab manual and read pages 3 through 5 for a recap of some of these things that we talked about, and fill in the blanks for more practice with this vocabulary.